Hello. Thank you for participating in my research. So, my research topic focuses on integrating computational thinking into simulations and how it affects to students' conceptual understanding and problem-solving skills. So, as you know, co- problem-solving and the conceptual understanding directly proportional to each other. So, here, before the start, I would like to introduce one research. This one PhD students created computational thinking model in US, so which covers four model. First one is the pattern recognition, abstraction, decomposition, and algorithm design. So it's here also given what is the computational thinking and the definitions of these frameworks. So what is the computational thing? It's this kind of thing, that this kind of model, your problem solution should be understandable both for students and the computer, or computer solution should be understandable for students. Okay, so uh, I today I would like to integrate this model with the simulation. I would like to see the effect of this integration. Okay, I have chosen this full start simulation. It's very user friendly. They have kind of type of circuits you can they have a lot of equipments also, so it also gives real life diagram. So I have chosen this problem. It might be very easy for you, might be very simple problem for you. I will just only solve A and D parts. So at the D part, at the A part, they are asking potential difference across this capacitor after close the switch. So after a long time. So at the first pattern recognition, yes, pattern recognition means that what is in the circuit. In our patterns, we recognize this resistance, capacitor, battery. That's our first pattern. The second one is I can show it by the simulation. When I close this switch, this voltage across this capacitor gradually increases. Yeah, so this gradually increases. Speed of charges gradually decreases. So this one is our second pattern. This one increases, current gradually decreases. After the last one is after a long time, current becomes almost zero. Yeah, that's our patterns. So second module is the abstraction. Abstraction is means focusing on what is the important and ignoring details that distract us. So in our problem, all of these elements are ideal. So ideal wire, ideal resistance, ideal capacitor, and the room temperature doesn't change. As you know, the temperature also affected wires resistance. So all of the ideal case. So abstraction allows students to focus on core physics, not real world imperfections. Okay, so for reaching our main idea, we have to ignore unnecessary details. Okay, it helps in our problem. Also, this simulation helps us creating ideal circuits. Okay, so also you can create real life battery, real life capacitance with the resistance. Okay, but in this case ideal. Also we ignored undetailed things. So third one is the decomposition. Decomposition breaking problem into smaller steps. Okay, for example, let's focus on our A part of this problem. We have to find potential difference across this this capacitor. So after a long time closing the switch, so Decomposition is that we have to divide into smaller steps. First one is we can solve this problem by Kirchhoff law, loop law. Let's say it's the total potential difference equals to 0, or we can solve this problem parallel series connection. In our case, the parallel circuits, we can solve it. This our first step, or first part. Okay. The second one is we need other equations, like we have to know this Kirchhoff loop law. So we have to know how Kirchhoff law works. For example, let's focus on one more thing is that here last one is the algorithm. Algorithm means that step-by-step solutions, and check predicted value, predicted final answer with the simulation answer. Okay, you can compare with the simulation. This one is our algorithm. So let's focus on the third composition. So it might be very easier for you for this B-level problem, but for Olympiad problem, it's a third model would be very helpful for us for breaking down into small parts. Okay, so let's solve this problem. The third one is the decomposition. Okay, so first one is the you have to choose travel direction. Let me choose this clockwise direction. So when I jump from here plus to minus, its potential difference. Okay, potential difference will be minus. Yeah, the main equation is that total potential difference is equals to 0. So it will be plus battery's potential difference. So current. The second one is the current flows plus to minus. Yeah, when we close the switch. So when potential difference of this resistor will be minus, because potential difference resistor resistor will be minus this Ohm's law. We have to use Ohm's law. This is our second decomposition. Ohm's law, Kirchhoff law. So it will be minus. So here minus IR. So third one is that we have to know third decomposition, it will be plus. Yeah, this side of capacitor will be plus. That's my second one is a minus, because this is one plus, this should be plus also. Okay, so last one is potential difference of this capacitance is minus and equals to 0. So then this simulation helps us the main core physics and conceptual understanding. For example, I reset this one. You see, at the initial current is the maximum, so it gradually decreases over the time. From us, that they are asking after long time. What it means after long time? After long time means 1 hour, after 2 hours, 1 day, and so on. So after long time, this speed of charges stops. Yeah, it becomes stop. It means that current is 0, because the definition of the current is I equals to dq over dt, charge of speed. Actually, this is our third decomposition definition of the current. So current will be 0 after long time. It means that potential difference of capacitor equals to voltage of battery. It will be same. Okay, this one is the decomposition and the abstraction. So you see the step-by-step they have step-by-step solutions. We solve we wrote this Ohm's law, Kirchhoff law, definition of the current, and the final answer. Okay, that's our step-by-step solution. So last one is that we have to check this as predicted value with simulation. You see, potential difference across this capacitor will be same with battery's voltage after long time. You see, after long time it will be same with here, you can see. So let's move to last part of this problem, D part. So find the expression for current I versus T graph. We have given two cases, T is 1 is T0, T is 5 tau. So first one is the main important thing is here, the second definition of the pattern recognition is you have to rewrite pattern recognition. The main thing is here, you see, definition of the pattern recognition, considering how similar problems have been solved previously. Қазақша түсіндірсек, балалар осыны pattern recognition кезде былай түсіну керек. Мен мынаны білемін ғой, мынау резистор мынау екен, мынау бізде voltage деген сияқты. Өткен есептегі идеяларды екінші есепте қолдана білу. Мысалы бізде A партындағы бүткіл идеяларды екінші есепте тани білу. Мысалы voltage мынау current уақыттың өтуімен азайып жатыр, бұлардың барлығы тани білу да, чтобы екінші есепті шығару үшін. Okay, the second pattern recognition already we have to take information from first part here. Okay, so second one is the abstraction. We already talked about abstraction. Is same things here, ideal wire resistant and volt battery. So third one is the decomposition. What kind of steps do we need for solve this problem? First one, we have to draw I versus, let me take T over tau graph. Okay, how it changes over time when we close this switch. So the first decomposition step is the drawing this diagram. So let me show you by circuits. So when time is 0, the current will be maximum. Yeah? So here, second step, we have to know instantaneous currents equation. It equals to I maximum exponential multiplied by exponential minus 10 T over tau. The tau is RC. So first decomposition is the graph, second one this equation, third one is this one. So last decomposition is here. When T is 0, it will be I equals to I max exponential minus 5. Yeah, that's 1 or 0. It will be 1. Yeah, it means that instantaneous current will be same with maximum, and time is when time is 0. It means that instantaneous current after switch closed immediately, you see, current will be maximum here. That one is our decomposition. That last one is the abstraction. Abstraction is the step-by-step solution. We draw it like curved line, gradually decrease with this curved line. So we wrote equation of the current, kind of this steps. Okay, and the last part of abstraction is algorithm is the check predicted value with simulations value. Okay, you have to check it with predicted value with simulation value. So you see, when time is 0, this horizontal line that shows us time. This vertical one is the current, with yellow. So at the T is 0, current will be maximum. Okay, This one is our problem solution with this model. So here I uploaded all of information. This one is article, this topics which you have to solve. So first problem, you have to solve this problem. I have to taken this iPad problem all with the solution, but you have your work is the explain with this model, okay, for first week's task for you. So before they solve this problem, iPad problem, you have to take one B or A level problem before this problem, okay. So deadline, the second for second week you can choose your own problem, one B level and one C or iPad problem. I took only 4 topics. So what else? If you have a question, you can contact direct to me, okay. Thank you so much.